Okay. So here is what you're doing today. Before I get into your notes, I just want to show you what we're up against. Okay. Draw you a circle. I'll give you a radius of let's say 10. And go like this. Call that your angle around the circle, and I'm going to measure your angle. Here comes your angle measure. It's this number. 2. What am I in? Am I measuring in degrees or am I measuring in radians? How do you know it's radians? There's no degree symbol. Without a degree symbol, you're in radians. Okay. Well, here's what you want. Today, you want this. I want this distance from here to here. Okay, this is what I want. What do we call that distance? We call that distance arc length. Okay, so arc length, otherwise known as, they use capital S. So instead of arc length, it's just S. So how far is it from here to here? And if you listened yesterday, you could probably tell me the distance right now. Brady has his hand up. Anybody else want to try it? Okay, Brady. Okay, Sophie, you think you can tell us?
Is it 20?
She says, is it 20? How'd you know?
The radius and those two.
Okay, so the radius is how far?
10.
10. And when I say radians, I'm telling you, take the radius, wrap it around the circle how many times? Twice. And I don't mean around the circle, I mean only from here to where? Here to here. So how many of these radii am I wrapping around the circle? 2 of them. So here would be 1 radian, here would be 2 radians. So this is 10, this is 10, so what's the answer? 20. She's right. So how do you get arc length? You do what? Tell me the formula.
Radius times radians.
Radius 10 times, you said what?
The amount of radians.
The amount of radians in your angle 2, and you get your answer 20. Does that make sense? Yeah? Okay. I got people going like this, and I got people that aren't even moving their heads, so I don't know about people that don't move their heads. What if the circle gets smaller, and I go like this, and I say that's 3 inches, and down here. This is the angle. And if I give you that angle in, let's say, radians again, and I'm going to call this one, you can't see that very well, I don't think. Let's go like this. This way, this way. Let's call it 4/3 pi. So around, how far did I go around the circle? 4/3 pi. That's the angle. And how do you know it's in radians? There's no degree symbol. Without a degree symbol, it's in radians. So what's the arc length here? The arc length would be from there all the way to here. Now here it was easy. It was just a number 2. Take 2 of these numbers, wrap it around the circle. What do you do now? How many of these little 3-inch radii can I wrap around the circle? Well, this number is telling you. What is that number?
4 pi.
It's actually 4 pi divided by 3, which is like whatever. So don't you just take this number and multiply by that number? Isn't that the same as this? Yeah, so you'd say, how many of these radians do I have? I have 4/3 pi times, what's the radius? 3 inches. So, oh no. Guess what I just did? I think this is your example. I'm sorry. I think this is the first example. So the arc length will be, help me out guys, what would you do to multiply those 2 fractions? not cross multiply, because this is a fraction times a fraction. You're thinking equation. Wouldn't you just cancel those 3's out? Yeah. What's the answer? 4 pi.
It's not the example.
It isn't? Good. Okay. Okay, guys, tell me this. What's the answer? Now remember, I'm in inches, so the answer is 4 pi inches. That's how far I've traveled around the circle, or better yet, punch it in. What's the answer? To the nearest, let's say 10th.
12.6.
12.6. Okay. All right. The exact answer is 4 pi inches. The approximation is 12.6. Are you okay? Okay. So now, somebody out there, tell me the formula. What's the formula you're going to work with today? How do you get arc length?
R times the angle.
R times the angle. R stands for what though? Radius times the angle. And the angle I'm going to give you, I'm going to call it theta. And guess what? Theta must be in what? What? Radians. Good job. There you go. Now, without looking at the notes, hey guys, without looking at the notes, we figured it all out. This is the only concept today. Today, I'd like you to give me arc length. Well, how do you do that? You take the angle given times the radius. The angle given must be in radians, or else it's not. You can't get the right answer. Okay, so if I give you this angle in degrees, guess what you have to do? Convert it into radians. Exactly. Okay, go do number 1 right now, because I think you know what you're doing. All right, here we go. Your formula is right here, and I do want you to maybe underline that 3 times. You will use this formula every time. Arc length S equals R times theta, and theta must be in radians to work with this formula. Show me your answer when I walk by you if you have it. Yeah, it's this first
Tell you the.
one. You're up here. Go to this. Yeah, I'm right there. Yep, I'm right here, guys. Hey guys, I'm right here now. You want arc length of B. There's B from there to there. Okay, what angle made up that arc? This angle right here. This angle makes up that arc. So, do we have enough information right now just to plug numbers in?
Yes.
Do we have the radius?
Yes.
3 inches? Okay. Do we have theta in radians? Guys, from here to here is how far? How far is that from there to there? Yeah, 2/3 pi. Is that radians or is that degrees? That's radians. So you're going to say 2/3 pi times 3 inches. 3 inches is just 3/1 equals arc length. Cross out what? 3 with a 3, and the answer becomes 2 pi inches. So you have traveled how far around the circle? 2 pi inches. I mean, that's the answer, but wouldn't it be nice to kind of know a number? So what's 2 times pi? Approximately what? 6.3 inches. Okay, it did say round to the nearest what? 10th, that's why we did that, right? Okay. This was a very straightforward problem. They gave me the radius, they gave me the central angle in radians. There's nothing to it other than plopping numbers in and working it out. Okay, try the next one. Point at your answer when you get it. Yep, that's it. You might just go to the next one.
Yeah, in centimeters, I think.
Okay.
I think.
You get it? Where's your notes?
I lost them.
Well, you gotta ask them. You're kind of waiting for me, I think, right? It is S, yeah. Arc length is always gonna be S. Oh, no. This has a radius of 7. Do not look at this circle. You're on a different problem. So maybe what you guys should do is draw a different picture for yourself. Okay? Do not look at the previous drawing. Anybody got it back here? Okay, go to the next problem. You don't have notes either? Hey guys, when you don't have notes, say something. I'll get you notes. Anybody else? I got Tate, I got Hunter. Anybody else that not have their notes? Okay. Yes, move on. Exactly what you need. And then if you want to approximate it, punch it in. What did she do? Oh, you look at that. Yes, you do have it. In the direction.
What?
All right, I think I checked everybody. Some of you didn't quite have an answer, so I couldn't do much. You guys laugh at that.
Another G-spot. You go.
Okay. All right. So here's me thinking, okay, radius of what? 7. Okay. Oh, I don't even see my angle up here. Find the length of an arc with a radius of 7 centimeters and an angle of? Okay. So if I do negative 135, it just means I'm going which way? Down. Okay, so if I start here, I'll go down, 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 about here. So to me, this is my measure, okay, but it's not in radians. You got to get this in radians. So you need to take your angle, negative 135, convert it by multiplying by what? If you want radians, didn't we say put radians where? On top, angle on the bottom. Knock out the degree with the degree. Once you knock out the degrees, guys, we're out of degrees. We're in radians right now. So to me, the answer becomes this over this. Tell me, is that reducible?
Yep.
What goes into both? What number goes into both? I heard 5. Okay, I'll do 5. Even though you could have picked a bigger number. 5 goes in here 36 times. 5 goes in here 27. Okay. It's still reducible. 9 goes in here 3. 9 goes in here 4. So the final answer is correct? So really, guys, you moved where? What's your measure? In radians. Okay, in radians, the central angle is negative 345. Now, I gotta ask you a question. When it comes to distance around the outside of the circle, is the distance around the outside of the circle ever gonna be negative? If I go this way and measure, that's a positive distance. If I go this way and I measure, that's a positive distance. It's just distance is positive. Do you really have to put the negative in? No. Here it comes. This arc length S should equal the radius 7 centimeters times the angle 3/4 pi. Your answer for S becomes 7 times 3 times pi is 21 pi over what? 4. You know what that answer is?
16.
No, but that's your exact answer. This is the answer in what? In centimeters. The only problem I have with that answer is I don't know how long that is. How long is it from there to there? That's why I always kind of punch it in. And when I punch it in, I get the approximation. Wasn't it 16.5 centimeters? 17 or 16.5 centimeters, or if you want the exact answer, it's 21 pi over 4 centimeters. Okay? Half of you had it. Half of you were working on it, but not half. Some of you were still working on it, and then some of you didn't know what to do. Okay, so now are you okay? Is everybody okay? The trick is if I give you degrees, convert to what? Radians. If you don't do that, you won't believe this, 20% of the students will not convert it. They'll punch that number in and get this whole thing wrong. Okay? All right, let me give you about 2 to 3 minutes. One person got this right in period 4. Just one. Your brother had a pretty good guess. But no, he was close. Take 3 minutes. If you've already got it, because I already sent a few of you on, show me.
Huh?
You gotta think like this. It's a satellite. What does a satellite do? It goes in a circular motion. Haven't we been doing this? I mean, what's the how far around the head do the satellite draw a separate picture off to the side?
The little blow thing up, like, it's gonna blow up on all people.
It says how far did the satellite travel in 1 hour. That's what it says, right? Yeah. Okay, keep reading. Just read very closely because it's all there for you.
Yeah, I'm
All
trying.
right.
Mr. Painter,
Yeah.
check.
Mm-hmm. Okay, just quick.
You want it in
Yes, but that came from what?
radio.
Okay, because that would be this. That's what it's about. You gotta think of it. See, everything's just this. What's wrong with this? So, why do you say that?
Because you think of like, if it actually is like, there's a hair pull circle, then this is really high, and just take straight up
Okay.
and
Did
this
you
is-
just kind of visualize it and say that?
Yeah.
Well, the trick was it travels around the. So, do you want to start here? Well, you want to know how far one.
Yeah,
So
so I just
one.
divided the circle.
To me, it's in 1 hour, you got 1/4 of the circle. So, yeah. it's- I thought you visualized it.
I know, I have one number.
I'll do it that way. You gotta know what fractional part of the circle it really is. So, like, if it was that. In 1 hour. Or 2 hours. What's a circle? So 1/10 would be the answer in radians. Yeah, you know. You know. Hey guys, if you get it right, go to your assignments. I've got one person who has it.
Good.
Dave. Hang on, I gotta think how that was written.
Hey, if you just like,
Is this the?
Oh, wait. Yeah, that is right. I haven't seen it written like that, Brady, but that is right.
What does that do?
Can you change it to a decimal?
Sweet things, treacle date thing?
Yep.
Sure.
Something I want to know. Oh, right now?
I mean, it's not.
Anybody want to show me? Maybe you got it right? Maybe you did. Yes, yes. Yes, no? Okay. All right. You got it, Cam? No, you got it. You got it. Okay. Okay. All right, guys. Can I just show you something? Because guess what? You're going to go to the book, and the book's going to take this problem and just twist it on you a little bit. Now, can you just tell me this? If the satellite, hey, if the satellite goes around the world and ends up right back here, guys, listen. If the satellite goes around the world, ends up here, how many radians is that?
4.
Okay, one revolution, it goes around the Earth. How many radians is that? 2 pi. Guys, if it goes around the world, it goes 2 pi radians. Right? But the thing was, it said in how many hours? No. It does one complete revolution in 4 hours. Okay. All right. So here's the question. What part of a revolution
Excuse me.
did it take?
God bless your soul.
Okay.
Is that for
So guys-
intrusion stage?
Listen. Here's the secret. Now look, we only want 1 hour, don't we?
Freedom.
Okay, here's the deal. It takes 4 hours to go around the planet. So what fractional part do we want? Yeah, we only want 1 out of the 4 hours. So we're looking at part of the revolution did it take? It took 1/4 of the planet, of the circle. 1/4 of the circle. If the circle is 2 pi, then you take the circle and you only went 1/4 of the way. So guys, what's 2 pi times 1/4?
90.
2 pi over 4, or better yet, it's 90. You guys, we went pi over 2 around the planet. Yes or no? Did that make sense?
Yeah.
Okay, so guys, looking at this picture, you got to understand the circle starts in the middle of the planet and it goes this way, which is 6,400 kilometers to get to the edge of the Earth. Add another, how far to get to where the satellite is? 3,600. So guys, what's the radius from the center of the Earth to where the satellite is? 10,000. Okay, kilometers. Okay, you have to understand to get the radius, you take center of the Earth to the edge of the Earth plus the edge of the Earth, how high is the satellite? Add those two together, 10,000. Okay, what's the arc length, which is what the satellite traveled? Wouldn't that be from here to here? Right? So you take what? R, your radius, times what? What was the central angle? Right there. We said it's pi over 2, didn't we? Okay. 10,000 over 1 times pi over 2. I think I just canceled the 2 once. 2 goes in here. 5,000 times. What's 5,000 times pi? That's the answer. 5,000 pi kilometers. Now wait a minute. Did it say round to the nearest anything? Never did? Okay. I bet you most of you punched it in. And when you punch that times that, you end up with 15,700. Okay, if I go to the nearest kilometer, that's it.
Yeah.
Okay. This problem will show up on a quiz. This problem will show up on the test. This problem might even show up on a homework quiz. You gotta get a feel for it. Go to your book right now and try it. Where is it is the question.
Game 34.
Big guys.
Colt, yeah, you get it, you know.
We'll take a 6-0 win, guys. 6-0. Alright. Alright, guys, let's go find this problem.
It's on 34.
Should we go?
Okay, yep, 34 guys, go. Okay, Bryce, 34, go. Car, 34.
Yeah.
Let's see you get it. Page, I don't know, it's gonna be 13-3. Draw a picture, it's easier. You can do it on the bus.
Where you ladies going, Jess?
Okay, Bryce. Alright. Let's see, let me do something down there.
How can you tell quadrants?
How can I tell what?
Quadrants.
1, 2, 3, 4. Is that what you're asking me? Yeah, one's in the upper right, two's in the upper left.
Hey, Mr. Payton,
Yeah.
the next month will be 3/14. Can you bring a pie for the pie day?
Are you gonna bring mine?
Are you?
Are you?
I asked you.
No, are you?
I don't have a clear
You're
shot.
Okay, you guys can do it.
Oh, we're doing 34?
Bryce,
6.
Bryce. I had that up there. Okay, what was the radius of the circle? Just curious, what'd you do? I can't hear you. You said something, but your hand was on your mouth.
6,400 plus 3,800.
Okay, car says 6,400 kilometers. That's from center of the earth to the edge of the earth. From the edge of the earth to the satellite was 35,000 what? 800 what? Kilometers, okay. So your radius is 42,200 kilometers. That's the radius. Good? Okay, this satellite goes around the earth in 24 hours. So guys, 24 hours equals 1 revolution. And be quiet, please, because this is everything. You need to tell me. The question said, how far does it travel in 1 hour? Hey guys, look. It takes 24 hours to go around the planet. You only traveled this far in 1 hour.
6 to 5.
So guys, what fractional part is this around the circle? What fractional part is that around the circle?
1/6 pi.
But this piece right here is 1 out of 24. You've traveled 1/24 around the circle, and the circle is made up of how many radians? One revolution is what? 2 pi. To go around the circle is 2 pi, but you've only gone 1/24 of the circle. So multiply, and you get that, which means this is your angle right there. Whoa, good. Got it? Did anybody get that problem, by the way? No?
What?
Did you get an answer? Did you get an answer?
For which one?
24, 34.
34, how many, which hours?
1 hour.
1 hour, 11,047.9.
Yeah, I rounded to 48. Yeah. So then you got it.
Yeah.
Okay. We'll look at that one tomorrow.